Bismillah ar-Rahman ar-Rahim. Dear student, today inshallah we're going to talk about chapter 7 that summarizes the transport layer. As we have mentioned before, the transport layer is responsible for managing the communication between two end applications, whether these applications are client and server or peer-to-peer, whether these applications are for email, for FTP, for telnet, whatever. So the transport layer breaks down the communication into what we call segments, and then it makes sure that these segments are delivered on the other side if reliability is required. Also, it performs some error handling to make sure that arriving segments are arriving correctly. So this chapter is divided into two major sections. The first one is to summarize the overview of the transport layer protocols and see what are the main functions of transport layer protocols and when do we need each of these functions. And the other major section summarizes the TCP and UDP as two examples of the transport layer protocols. So to start, transport layer protocol has the main role of managing the communication between two applications. So those are two applications in the TCP/IP protocol model, and the transport layer protocol is responsible for managing the communication, and it does that by tracking the individual communication between the applications. So on the sender side, we need to track the where the communication is coming from, because the sender may be running multiple applications, so we should track where this communication is coming from, and also segment the information that we are sending. So we should divide it into segments and send these segments on the other side. Also on the other side, we need to reassemble these segments, and then we need to send these segments to the proper application that is running on the other side. So we'll see how we identify the application that is sending and how we send the arrived segment to the proper application based on certain mechanism. So tracking the individual conversation, as we can see in figure 1 here, one host may be running multiple applications. Some applications are used for email, some applications are used for instant messaging, for web pages, for IP telephony, for streaming video, and so on. Each of these applications need to be tracked, and all the communication that is coming from these individual applications need to be tracked. So that's the first responsibility for the transport layer protocol. The other responsibility is segmenting. So all the communication that is coming from all these applications, it needs to be divided into smaller segments. And the benefit of that, we talked about it in previous chapters. So we need to divide the communication into segments. And that's mainly because most of the networks, they have some limitation when it comes to the size of messages that should be sent over these networks. So we have to divide the content of the application into segments. And as we can see here, we also do multiplexing between the different applications. We multiplex the segments that are coming from different applications. On the receiver side, when we receive these segments, the receiving host needs to identify where this segment should be sent to. For example, this red segment here should be sent to the email application, whereas the yellow one should be sent to a web page, and so on. So the receiving host needs to recognize where the segment is going to, and that's also the responsibility of the transport layer. As we have mentioned, the individual communication or the individual segments that are coming from each of these applications will be segmented and then multiplexed. So segmentation and multiplexing are done in the transport layer to track the different communications. And of course, multiplexing makes sure that these applications can run at the same time by dividing the resources of the connection between the multiple applications. So multiple communication or multiple connections can communicate at the same time through what we call multiplexing. This figure here is quite important because it shows us that we potentially could have multiple protocols running in each layer, and we need to have some mechanism to allow us to send the received protocol data unit to the proper protocols through what we call the protocol or something like this. So, for example, we talked about in the network access, we talked about the protocol field, which allows us to identify the protocol in the network layer. IP also uses a similar field to indicate whether upper layer uses or should use TCP or UDP. So we have two possible, the most common two possible transport layer protocols are TCP and UDP. So we'll talk about these two protocols in details later on. So as we have mentioned before, IP is responsible for routing the individual packets through the network, but it does not control how these packets are transported and what kind of reliability required. So the transport layer protocol performs that using some reliability mechanism, which we will talk about. So TCP is one of the examples of the transport layer protocol, which provides some reliability, as we will see. It's full-featured. It performs some reliability, some connection-oriented communication, and it provides some flow control, and so on. While UDP, it provides the bare bone service where you have the basic functionality of sending individual datagrams without performing any reliability, as we will see later. So transport layer protocol, the TCP as a transport layer protocol is a reliable transport protocol, and this means that TCP includes the processes to ensure reliable delivery. So as we can see here in this scenario, TCP is used to manage the connection between a client and FTP server. So in that case, providing reliable communication means that the individual segments from the client will be sent to the server as individual segments, and then the server needs to acknowledge the client that it has received all these segments. So it should acknowledge the fact that the last three segments have been received, and only then the client can send another three segments. And if they are lost, then the FTP will not send an acknowledgement. So in that case, the client will wait for a timeout, and then after this timeout, the client will send another three segments, and so on. So this kind of reliability is provided by TCP in different services like FTP or Telnet or any other type of application. Unlike that, UDP, for example, does not provide reliability. So there is a service called TFTP, which we will probably talk about later on in the application layer. And this TFTP uses UDP. UDP provides the basic functionality where there is no reliability. So when we send segments, we don't wait for an acknowledgement in that case, in which case we just send the individual segments, and these segments might arrive here unordered, in which case some of them might arrive out of sequence, or maybe they may never arrive, in which case the client has no way of figuring out whether these segments have been delivered successfully or not. In some applications, this might be acceptable because these applications, they tolerate some loss of information. As we have mentioned before, video is one of the applications that tolerates some kind of information loss, in which case UDP will be more attractive than TCP. So the reason for that is that TCP maintaining this reliability requires some kind of overhead, which we will talk about later. So in the transport layer protocol, depending on the requirements of the application can provide fast transmission, low overhead, and the application does not require any acknowledgements, and it does not resend the lost data, which means that the application is tolerable in terms of packet loss. So this set of requirements calls for the use of UDP, while on the other side, if the application requires some reliability and some acknowledgement for the data, and if the data is lost, it needs to resend the lost data, in which case you need to use TCP. An example of services that uses TCP are SMTP, POP for email, and HTTP, and FTP, and Telnet, and some other applications. UDP, for example, is used for streaming video. As we said, this video is one of the tolerable applications for packet loss, and in some IP telephony applications. So despite the fact that UDP does not provide any reliability, it's maybe more attractive for some applications that requires very low overhead and very fast transportation of the segments.